now we are going to discuss some of the compounds of alkali metal and metal hydroxides, their properties, their stability, their solubility, or if there will be a basicity or alkaline acidity, that also we are going to discuss. So, first of all, we will discuss metal oxide and hydroxides. So, first of all, metal oxides. Alkali metals form normal oxide. So, in a normal oxide, the oxygen has an oxidation state of -2, then peroxides where the oxidation state of oxygen is -1, and superoxides, that is MO2, where the oxidation state of oxygen is -half. All these metal oxides are strongly basic in nature. So, all these metal oxides, when they react with water, giving you metal hydroxide, MOH. Okay. So, metal hydroxide, and all are basic in nature. All alkali metal oxides are basic in nature. When I am talking about alkaline earth metal oxides, so alkaline earth metals form normal oxide -O and peroxides, that is MO2, and actually that is by beryllium, strontium and radium. Okay. Then all these metal oxides, when react with water, giving you metal hydroxides. Except beryllium oxide, other metal oxides, alkali metal oxides, alkaline earth metal oxides are basic in nature. Same way, beryllium oxide is amphoteric, so it reacts with acid as well as alkali, covalent, and has network solid structure. So, when I am talking about network solid structure, this is the arrangement of beryllium oxide structure. Because beryllium has vacant orbital, beryllium oxide has vacant orbital, the electron pair can be donated by oxygen to the vacant orbital of beryllium, and there is a formation of coordinate bond. So, this is the structure of beryllium oxide. So, that is the network structure. Now, when I am talking about oxides, it is important to understand the hydroxides also. So, we will go for metal hydroxides. Alkali metal hydroxides are highly reactive and their basicity goes on increasing as we move down the group. So, now we will write this way about the properties of metal hydroxide. Properties of metal hydroxide. First property is ionic characters. So LiOH is a covalent, okay, and the ionic characters goes on increasing as we move down the group. So LiOH is less ionic than NaOH, than KOH, than CSOH. This way. Basic character, basicity, the order of basicity. So as we move down the group, basicity goes on increasing, same way because of the low ionization potential. All these are strong bases. So I can say this way, MOH dissociates completely in aqueous solution, but the relative strength of the basicity increases as we move down the group. So LiOH is less basic than NaOH, than KOH, than RbOH, than CSOH, but all are strong bases. All are strong bases. All are strong bases. Solubility. All are soluble in water, because here the lattice energy is less than that of the hydration energy. So solubility is due to low lattice energy and high heat of hydration comparatively. Okay. Now, when I am talking about alkaline earth metal hydroxides, which is MOH twice, except beryllium hydroxide, all other metal hydroxides, alkaline earth metal hydroxides, are basic in nature, and their basicity goes on increasing as moving down the group. So I can say this way, same way for ionic character, if I consider ionic characters, MgOH twice is more covalent than CaOH twice, than strontium hydroxide, than barium hydroxide. If I am talking about basicity, the order of basicity, so MgOH twice is a weaker base than CaOH twice, than strontium hydroxide, than BaOH twice, barium hydroxide. Solubility increases down the group, same reason. But beryllium hydroxide is amphoteric in nature. So beryllium hydroxide can react with acid, giving you this salt and water. Similarly, beryllium hydroxide reacts with NaOH, giving you Na2BeO2. Okay, so here I should write 2H2O, 2HCl. Okay, here I should write 2NaOH. This way. So there is a formation of salt, sodium berylliumate, and this is beryllium chloride. So, now we have to discuss the properties of metal chloride, and then we will go for some of the compounds of the S block elements. Thank you.